Okay, let's get started. I'm glad that there's so many of you showed up on a Monday morning to the ACE working group meeting. We have a fairly full agenda. My co-chair Kiping is unfortunately not with us this time. Some other meeting conflicts, but in spirit he's with us, so he might actually be on the remote side. We have, so you know the note well, so if you're aware of any IPRs, you need to file them through the IETF web pages. Sean Turner is looking at the Jabber to make sure that we can relay some questions. Ari is going to take the meeting minutes. And I've passed the blue sheets around already. Please add your name there. As usual, a quick status on where we are with regards to the milestones. There are 2 items on that list that we are still working on. The FDAS document is actually one of the first items on the agenda. We'll see how we are going to complete those. The milestones are a little bit out of date, so we need to adjust them and get something more realistic, but we can discuss it when we get to those individual items. And there's also obviously the need to, based on, well, not obviously, but there's maybe the need to add some other milestones depending on how the discussions go. And we'll have to discuss this also with the chairs to see what that would be. But in a nutshell, we are a little bit behind. We need to speed up on some of the items. Yeah, so this is obviously the full agenda. We have the CBO web token is something that is not listed as a milestone. I need to add that, even though it's a working group document already, and also the ACE profiles. But there are a couple of other items after those working group items that we had received documents for. We're going to discuss them and would like to hear your input on whether you see that within the scope of the working group or whether you actually are interested in reviewing, contributing, implementing, and deploying some of those technologies. So it's a lot of stuff. So we'll keep pushing. We had an intro meeting. I think there's still a chair over there. Yeah, it's a little crowded today. There's still some chairs in the middle. Yeah, so we had one intro meeting, virtual intro meeting, i.e. a conference call in February, where we discussed the security for the low latency group communication. And Kiping did a call for adoption. And I believe if I correctly summarized it, we found out that that a couple of people who would like to see changes to the document, which is listed here as open issues. So they want to see those changes and will have to make proposals for changes. For example, clearly listing the requirements and the scope in the document, etc. But there were also objections. So we'll make those changes and then we see where we are in moving this forward. So I didn't see it since that just happened recently. Also the call for adoption, we didn't see a need to have a presentation yet again because these other things happened just months ago. Okay. It is clearly a more passionate discussion. Good. Carson, I think you are first.
Yeah, this is the second time, and probably going to say approximately the same thing. This is an informational document that always gets pushed documents. We do have some reviews that the editors of this document still have to integrate. We are about half done with that and submitted that half-done version as -05. But we still have to do the latter half of the document. And while we do have reviews, one question I would like to bring up that people can answer offline, maybe, is, are there any sections or subjects we want to drop from this in the latter half? I think the first half of the document is pretty solid, but we may want to compress the latter half a little bit. So people have an opinion on that, please state it on the mailing list.
Okay. So when do you think the document will be finished? What is the expected completion date?
I think it will be, the next round will be available in May. And if we do get some feedback on that, it might be done in Prague.
Okay. There's still some chairs left, so you don't need to stand in the back. Just squeeze in. I see chairs here, empty chairs here and over there.
While we are talking about squeezing in things, there's also one thing that was left from the last meeting when you weren't there, the Tudor thing, where we can squeeze that in at the end somewhere.
Okay. So a gender bashing thing. Okay. Good. Do we have any volunteers for reviewers on that document? I could take a look at it between now and in May. I know that some people volunteered already. So Elliot?
Yeah, I'll send you a one-liner.
You send a one-liner? Oh, sure. A reminder. Okay. Dave Taylor, if I saw him correctly. Good. Okay, that was quick. So hopefully we'll finish it by the Prague IETF meeting, so we get rid of this document. Mike.
Good morning, everyone. I'm Mike Jones from Microsoft. This should hopefully be short and sweet. I'm here to talk about the status of the CBOR Web Token document. Next. So when we last met, the one outstanding issue was we wanted there to be complete examples which were self-contained and could be validated by people. Thanks to some great work by Samuel Erdman, that is now the case. There are examples with full binary representations in the spec for all of the object types, using all of the defined claims. And people are encouraged to run your COSE and CBOR parsers and verify that we got this right. Next. So the only next steps that we see for this are hopefully we do get some independent validation of the examples. The question to the chairs that the authors would ask is it now time for working group last call?
So does anyone have objections against starting a working group last call on this document? It has been around for a little while already. It's not a complicated document because it just maps the existing CWT to the CBOR format. Good. I don't see any objections. Okay, so we'll do that.
I do have one question from the authors, and I think the working group. Given the dependence on COSE, where do we stand with getting that through the RFC editor? Almost done, according to Jim Schad. Thank you, Jim.
Ludwig, you are next.
Before I start, Ludwig Seitz, perhaps one quick question, Jim. Sorry, I was a bit slow, jet lag. There was this discussion recently about weaknesses in Jose work, and there was a question, I think, from Karsten on how that affects Jose and how that would affect Jose Web Tokens, because as far as I recall, the discussion was a lot around JOTs. Do you have any?
The funny thing is, I was asked to do a presentation, which I'll work on with Nat and John and some others in the SEC events group on this topic. The short version of that is that there's some cases where if you don't validate the inputs of some cryptographic functions, in particular the point used for an ephemeral key, you can follow one of the standard attack practices, which is provide bad inputs, see what the implementation does, gather information, rinse and repeat.
Okay, so it's a case of bad use, basically.
Yeah, and according to John, apparently, if you're in Java, this is now fixed in some of the Java frameworks. That being said, there's defense in depth that you may want to do in your application level libraries. There's another similar thing that people blogged about where they were asking the question, well, is it reasonable for applications to have to know whether the cryptographic functions used are valid? And at least wearing my normal IETF hat, applications always have to understand whether the cryptography that they're doing is valid. And if not, that's why we have crypto agility and you move on to new algorithms.
Thank you.
Very good question. Thank you.
Mike, maybe you can post a mail to the list with some of the pointers, so in case that people didn't know what you were just talking about. Some recent attacks, so if you are subscribed to the OWASP mailing list, you would probably have seen some of the posts. Antonio did a good write-up.
Yes, he did. After I have done that short deck with Nat and John and whoever else wants to contribute in time for SEC events, which is Wednesday, people can remind me to also send a pointer to that, to this working group.
Yeah, it's a good idea. Guys, come forward. I can contribute 2 chairs here. Just move them over here.
That's right. Welcome to the chair, Ludwig.
A couple of chairs still in the middle. Please take a seat, because otherwise at the end of the day you will basically not fall off the chair because you went on a chair, but
This would be a question.
okay.
You first.
Brian Campbell, Ping Identity. I just wanted to follow up a little bit on the discussion around JOT and the relation to, how do we say it, CWT? Anyway, there's a couple of different things. One of the issues that I think is being seen is very much related to the fact that there is cryptographic agility, and that the algorithms of these tokens or these items are placed in the body of the token themselves. And a lot of the attacks that have come forward, I don't think they're as serious in many cases as been sort of propagated, but is the fact that the algorithm designation is under control of the attacker in many cases, and the applications themselves are not being specific about what algorithms they accept. So that is very potentially relevant here. The other more recent one was an attack on elliptic curve Diffie-Hellman key agreement, which is different, but probably very much relevant here. A number of the platforms have sort of lower level protections in place. Some of them don't, and it oftentimes requires a point validation before you do the key agreement. So
yes, I think so there's some specifically with these, that JWT and the CWT is essentially a one-shot payload, one-shot message. And so you need to have, on both sides, need to have some understanding of what keys are you going to use, what algorithms are expected to be there. So if you, because we had this earlier attack that also, I remember from our security workshop we did, where people just took everything that was written in there. If if the attacker overrode the algorithm field with none, it basically then took that for granted and basically accepted that as well. Clearly a mistake of misconfiguration. So I think there are a couple of things one needs to be aware about implementation-wise. I don't know where to best capture this. Maybe some of the things are common sense, I believe. On the other hand, people still get things wrong.
Yeah, they are to people that are familiar with it, but people are getting it wrong pretty significantly. It's already sailed because Jose and Jose are out, but there's a lot of arguments in favor of not including the algorithm agility directly in the message itself. But the fact that we've made that decision at this point, there's probably a place for more obvious and stronger text about what needs to be done sort of at the application layer to use that safely. I know there is stuff in Jose, but it could possibly be a little bit more clear. So
okay.
I just wanted to clarify.
That's a useful comment to, and maybe we need to reread the document and see whether we could provide some of that experience and fold that in a fairly strong text.
Okay, so I'm Ludwig Seitz, I'm the main author of that draft. And basically this talk is about the updates to the draft. Next slide, please. So those of you who haven't read the draft will be really lost now. Major changes since version 4. There was a version 5 somewhere in between the last IETF and now. So I skipped from what you heard when you were at IETF last time to what you will hear now. I'm going to go into detail for some of these points, but I'm going to go through them quickly now. We have littered through the document text specifying what we expect from profiles. So this is the framework, and then there are going to be profiles that define usage of the framework for specific transport and transport security protocols. There was littered through the document text specifying what we expect from the profiles, and we decided this needed to be actually RFC 2119 language and not just you should do this and that with small letters. So now it's RFC 2119 requirement language. And there is an appendix summarizing all this text that is still littered through the document, so that if you don't want to read the whole thing and just want to get on with your profile, you can look at the appendix and hopefully you will already know from that what to do, although I doubt it. Anyway, next point is we're going to go in depth a bit, so I'm skipping it for now. More security consideration for proof of possession keys is also a slide about privacy considerations as well. There are even more IANA mappings. It turns out we forgot to map the OAuth error codes, so that's done now. And we defined CBOR abbreviations for them as well. So the IANA section of this document is starting to get really, really big. Review of that would be very welcome. It's really easy to sneak in small errors in those parts. I also reorganized the section structure because it didn't make sense to me. In the process of that, I noticed later, I broke all the references from the profiles. So profile authors, I'm sorry. I did that to you. Next slide. So grant flows and the authorize endpoint from OAuth. Quick note for co-op users, there is a different meaning to the word endpoint in OAuth than there is in co-op. And when I say endpoint right now, I mean the OAuth meaning. So the main grant flow we use in the moment, and I have in mind while writing the document and so on, is the client credentials grant. It's basically where the authorization server decides what access tokens to grant based on the credentials of the client, thus skipping the whole grant flow and going directly to access token request and response. And the question I would have here is, should we design a specific ACE grant, or do we think this is a good grant to work with? There are a few other grants that might be relevant that are also mentioned in the document, and that would be the authorization code grant. I seem to be having problems with the microphone. Authorization code grant And then there is a active draft from OAuth, that is the device flow grant, and that is also relevant because it's designed for devices without UI or with other limitations. So there's obviously a grant flow that is relevant for ACE. And I was told it is in OAuth for historical reasons, so it could just as well be here. Next, the authorize endpoint. So basically that is where you request grants, and it's not used for the client's credentials grant. And in order to do that, you need a UI on the client to answer the question whether you want to grant this. And so we decided this is not in scope for ACE, because we are thinking of mostly machine-to-machine communication and of constrained devices that typically don't have a user interface. Feel free to disagree with me here.
Ludwig saw a case where the interaction starts, let's say, on a mobile phone and a tablet, where there's obviously a user, and then that talks to an IoT device would be ruled out by that.
Well, not ruled out. You would use the plain OAuth grant flow for that.
That's good.
Then you could use the authorization code, for example, you get in this OAuth grant flow.
Okay, that's what you meant.
To do a authorization token request according to the ACE profile or the ACE framework. It's not ruled out that we don't want people to use it. It's just when you use it, you need to have a powerful device anyway, and then you can use OAuth as it is for that step. Next, security and privacy considerations. We've made some updates after comments we got. One comment was about tokens that are valid for multiple resource servers. For example, if they use an audience claim that several resource servers identify themselves with. And if those tokens use a symmetric proof of possession key, then every resource server that gets this token can impersonate the client. So we're saying in the security considerations, don't do that. It's a bad idea. Privacy considerations, I wrote one because I felt it's needed, the document needed one. It's very rudimentary at the moment. It basically talks about that the authorization server can track the client, especially if you use the client credentials grant, and that non-encrypted CWTs can leak information for attackers that can capture them. So basically, if you have sensitive information in your CWT, then you should use one of the encryption wrappers from COSI. And if you don't want your authorization server to track your clients, then you need to provide them with shifting anonymous identities so that the authorization server cannot link the token requests together. Thank you. Next. Client and RS registration. This is an appendix that has already existed in the last version. Just wanted to draw your attention to it. When I started implementing this whole thing, I put together a list of assumptions I made about what the authorization server knows about client and resource server. Please have a look at it. I would love to get feedback about that. I'm not going to go through it because I'm going to blow my time budget otherwise. Next, implementation status. So there is one Java implementations for powerful backend devices. It does implement the whole authorization server for the client credentials flow. And there is some libraries that you can use in resource servers and clients. The reason why there are parts missing, and the parts missing are mainly the client resource server interactions, is that to do that, you need to implement a specific profile. And the profile we're still working on. So I'm hoping that as soon as we get the profile stable enough that I can start implementing that, I can give you a full implementation. And I would encourage more people to start looking at that. I think the framework is in a shape where you can reasonably start writing code on that. Next. Profiles, we're going to have a longer talk about profiles, so I'm keeping this short. We currently have 4 profiles, co-op over DTLS, co-op using OSCOOP, MQTT over TLS, and publish subscribe with co-op. I would like to see a Bluetooth low energy profile if anyone feels competent and willing. And I had a talk with a gentleman yesterday who was interested in NFC. So I would encourage that as well. Certainly a relevant transport protocol. And I'm thinking we might want to start thinking about adopting profiles now, because you can't fully demonstrate the ACE framework without the profile. The profile regulates how the client talks to the resource server. And without that, ACE is incomplete. So let's adopt some profiles. Thank you. That was it, I think. Yes. Questions? Okay.
Everyone happy?
Or they didn't read the draft.
I have a question. So you've seen for the milestones, it's out of date. What do you think is a reasonable time frame when we are able to complete this work?
We don't need the implementations to do working group last call, I guess.
That's true, although you have done first implementation already.
Yeah, one. I think it's 3 independent, right?
No, not for that proposed standard. But we could, of course, do. So last weekend there was a hackathon. There was also an OWASP group doing participating in the hackathon, but they have been working on the native apps, their best current practice. So maybe we could at the next hackathon put that on the agenda as well.
Document-wise, I don't think there is much left to do unless someone has a big issue.
Mm-hmm.
So as far as the document is concerned, we could do a working group last call now.
Okay.
It's just now I'm actually focusing on getting this implemented.
Sure.
Selander, on this, I think it's a bit too early actually to ask for working group last call, because some of the things, the functionality we specify in the profiles need to work with the framework, and some of the functionality which is in the profiles today maybe should be included in the framework. So I think we should first have a couple of profiles demonstrating that it actually matches an implementation claiming compliance to a particular profile could also work with this framework.
But we have a couple of profiles.
None are adopted, but there's a discussion on profiles the next coming up.
Mm-hmm. So maybe we should sort of come back to that issue.
Yes.
Mm-hmm. Yes.
But so at least I would expect that the guys who work on the profiles to have actually read the framework and that they at least could provide some comments whether the profiles match the framework. You know, like it wouldn't be too far-fetched. So I guess I will just ask those people to do that, exactly that. Okay. Thank you, Ludwig.
I think.
Okay. So speaking about profiles, which is the next topic on the agenda. Next slide, please. So Ludwig already did a lot of the introduction to me on this topic. So this is based on an input to the mailing lists on where are we on profiles and what are the next steps. So I don't have to recap this, but what we know is that if we compare with OAuth, ACE is a profile of OAuth 2.0. If we compare with OAuth, it's quite clear what would be the communication protocol and the security protocol you would use. In ACE, that's not clear at all because there's a variety of different IoT deployments. So that's the reason why we have the profiles. So different profiles are used for different communication security protocols used between the client and the resource server. And as Ludwig mentioned, there is this requirements section in the framework specifying what a profile should contain. So it should be the communication protocol, the security protocol, what is the proof of possession method, how do you get the access token across from the client to the resource server, unless you're using the default method, what is the identifier of the profile, etc. So it's a number of requirements. And basically, what we have today is 4 different profiles which are somehow partially overlapping. And we need to have an idea of how we handle that. Next slide, please. So there are 4 documents that claim to be profiles. And then there are 2 other documents which are also profile related. So the first 2 are the oldest profiles. It's the co-op DTLS, which Karsten will say more about in a few minutes. And it's the OSCOA profile, which was presented and updated by last meeting. And these profiles are very, very simple. They basically say that here is a client, here is a resource server, it has some resources, and now I want to use, say, co-op DTLS to access this resource. And it describes what the client and the resource server needs to implement. And the same for OS co-op. But then we have these 2 new profiles, the MQTT-TLS and the co-op PubSub profile, which is slightly different. They are both looking at the PubSubscribe setting. They each contain multiple profiles. So there's one profile for a publisher. If a publisher wants to publish to a certain topic, and there's another profile for a subscriber. So they are describing a similar. And the MQTT-TLS I don't think is presented today, but the ACE PubSub PubSub profile will be presented later today. So they are slightly overlapping. And the same goes for the 5 and 6, which deals with multicast, where number 5, this is not documents which are profiles yet. They are, number 5 is a complete solution for authorization in group communications, which intends to be transformed into an ACE profile. And number 6 is just an appendix in the secure group co-op group communications draft, which is outlining on a high level what needs to be integrated into a profile for multicast.
Question: when you say 3 and 4 are overlapping, you mean overlapping in terms of the fact that they focus on a publish-subscribe model, but otherwise, like MQTT is obviously very different than co-op publish-subscribe. That's what you meant by overlapping.
Sure. So, and to the extent of the overlap between these, I think the main question I have is, I think you can go to the next slide already now. So this is the reason for having this presentation at all. What is the working group and the chair's view on how we coordinate the different profiles? So we have a number of proposals coming in, and it's not clear to me that we will not have multiple profiles specifying how to set up DTLS with co-op, for example, because that's used in multiple places. Or will they reference each other? How do we make sure that we are not adopting multiple documents specifying the same thing?
Mohit, so do you have like profile negotiation? Like if you have version negotiation, will you have something like ACE profile negotiation? How do I know about the other endpoint? Is it going to do co-op over DTLS or OSCOOP or something else? And like, how do you negotiate those things?
Ludwig Seitz, let me please answer that, since I wrote that part. We had in the earlier version of the draft a complex profile negotiation mechanism, and we decided it was over-engineered. So now there is instead an assumption, and that is that the authorization server knows which profiles the resource server supports and which profiles the client supports, because they at some point registered, and then it just selects the best matching one for the 2. So the client, when it requests its access token, is informed of what profile it is supposed to use.
Yeah, and on top of that, some of the profiles are you may have this static configuration or deployment specific, but some others may be just obvious from the context. So for example, if you use Bluetooth, there may be, as mentioned earlier, there may be one specific profile to use. You can't just run random other things on top of it, or NFC or so. Does that make sense?
So just a comment. So the complication here is not about negotiating the profiles. It's more like, from my point of view, how to specify the profiles to make them modular and they can reference each other.
Carsten Bormann. So if ACE ever gets around to a four-legged model, then profile negotiation would be between the two authorization managers and not involving the constraint devices, because the authorization managers know what the constraint devices can do. So what was the other point? Let me just go ahead and remember it in a second.
Okay. So back to the question. Do we need to control, instead of making one question, I should make two questions. Do we need to control this, or should anyone be free to submit a profile and we adopt that, and that's completely independent of the other profiles and may specify contradicting functionality, or should we somehow try to control, make the profiles reference each other and use the functionality of existing profiles? What's the view of the working group and the chair?
Well, I'm somewhat pragmatic here in the sense that, like, we're working in a working group and try to figure out what is best at a given point in time. And like, for example, if you have these 4 documents from the previous slide, and we notice that there's maybe some misalignment, then we just discuss it and as part of the review process, and we figure it out.
Okay, but say hypothetically that we adopt one draft and that's overlapping with the non-adopted draft. What would we do then? Should we take that into consideration, or because there are already overlaps? We could take the practical approach or just go ahead and see what happens. And if there is a conflict, then we solve it when it comes. That's
Michael Richardson. So yeah, just go ahead and remember that we're producing proposed standards, not internet standards. And if it should happen that after we've done 3 or 4 profiles, we discover that there's a bunch of common text that ought to have gone into the other document, and we do the BIS, we'll suck that text in. I think that's reasonable, because clearly that document underspecified something, so the profiles had to specify it, and we had to specify it repeatedly. Clearly we would like them to coordinate if they have to, but I also think, and I don't think it's a problem if someone has an unadopted document that says something different for a different technology. That's maybe unfortunate for implementers, but maybe there's a good reason. I think you should go ahead. And I don't think that this is like, I don't know, can't think of a good example, but I don't think like this is an alternative to SMTP and oh my goodness, what will we do? We've already deployed SMTP. I don't think it's like that. So I think just go ahead and I think we can be mature and reasonable about it. And it's faster that way too.
Carsten, I remember the other point I wanted to make. We just had this discussion about JOT being under control of the attacker in some way, and the profile negotiation or the profile selection, of course, can have the same problem. Now, the model says that the client and the resource server actually trust the authorization server. But the reality, of course, is that there are many applications where that's not true. And so if the authorization server can actually push in a profile that will make the client think it's talking to the right resource server or vice versa, then that's a problem. But that's a problem with a 3-legged approach, not a problem with profile selection.
So I think if we remove the assumption that the authorization server is a trusted third party, then we have a serious problem anyway.
But I think Göran is I think there are two separate issues. One is this negotiation, which we basically tabled for a later point in time and make it start with something sort of more static. The other one is that you're concerned that where we are really talking about process document overlap and how to deal with those.
Yeah.
Any other views on that?
And there's the related question then about functionality in the profile going into the framework. For example, the error handling, which is very, very well described in one of the profiles. Should we bring that into the framework, or should each profile have a separate error handling?
So I guess what Kipeng and I will do is we'll ask the profile authors to provide some feedback on the framework and see whether we can shuffle some content around or get some better alignment by doing that. It's fairly obvious that all the profile authors have read the framework carefully, and so I think that's a fair request. Or maybe not all of them, they just go in a write-only mode, but Ari. Is that okay? Okay. Carsten, so do I now have your slides?
You do, in your mail?
Okay. This is just in time slide delivery.
Yeah, we need a better publishing pipeline for this.
Let me just quickly upload that.
I'm running the event at the start of every term where every professor tells what they are going to do this year. And the slide aggregation for that is really a work of art. And we actually wrote a web application to get this right. Probably need something like this here.
So if you're watching from remote, you can now find the slides there. Sorry about the late delivery. Okay.
Okay. As you can see from the slide, this is really a large cast of people doing this work, and I'm probably doing the least amount of work here, so sorry about that. But yeah, next slide. So basically, this starts from the framework, of course, and we have a token request. We have an access token, and then the question is, where do we take it from there? And one idea is to actually use DTLS as the mechanism for getting the security we need, and use the DTLS handshake also as the proof of possession proof. So next slide. So once the access token is in the possession of the client, it actually sends that to the server, and that's interesting because it's at this point we are not protected yet. And then we go into the DTLS channel setup, and then we can do authorized requests to protected resources. So the DTLS channel setup happens in two modes. One is the RPK mode and one is the PSK mode. In CoAP, RPK mode is the mandatory to implement default security, and PSK mode is the pretty popular alternative to that. So next slide. Given that we are doing the initial authorization during the DTLS handshake, of course, one question that comes up is, what happens if authorization changes? If the client gathers new rights, for instance, then it can use the existing DTLS channel to update the authorization information in the server using the special authorization information resource that is provided by the resource server, according to the framework. Alternatively, the very simple client who doesn't have that mechanism could just renegotiate the DTLS session. So that's certainly always possible. Next. So let's talk about RPK. And yeah, I'm doing PowerPoint karaoke a little bit here, or actually LaTeX karaoke. Sorry about that. So in the token request, the client provides a client identity in the form of the CNF claim. Next slide. And the authorization server sends back an access token. And the access token essentially is useful only, valid only for the RPK that was given in the previous slide. So the client identifies itself with the RPK. The AS sends back an access token that is tailored to that RPK. And now, next slide, if the client then sets up one back. Do we have a? Oh no, it's just the last bullet. Sorry, that slide was deleted. So the client must use this RPK to set up the DTLS connection, because then the resource server can correlate the access token to the RPK, to the identity expressed by the RPK. So this is kind of run-of-the-mill. That's standard stuff. Next slide. In PSK mode, again, there may be information about an existing object with already an existing key ID. So that may simplify things, and that's one of the new ideas in the current version of the document, that we actually can use key IDs to identify keys and simplify some exchanges. Next.
So the audience, that would be the key ID in the CWT, and that would match the key ID or the identifier BSK identity in the TLS PSK exchange. Is that sort of the idea?
Olaf, can you answer to that via Jabber?
Ludwig Seitz here, I think I can answer that. No, that's missing here. So actually what you would do is you would include a CNF confirmation claim that would just contain the key identifier that you wish to use. And for the client, this is a way to indicate to the authorization server, look, I've already established this key with the resource server. I would like to continue using it. So here's the identifier. Please bind my new access token to this key.
Ah, okay. Got it.
So there's a part missing in the example here.
Thank you. Next slide. So the response from the authorization server to the client contains an access token, and the interesting thing here is that the access token is designed to be transmittable in the clear. Even though we are talking about symmetric keys here, the access token is designed to be used in the clear. And the other thing the client gets is the actual key, the PSK key, which is wrapped in a COSI key structure here. So you have to remember, we are the whole time assuming that the client has a secure channel to the authorization server, and we are not discussing how this channel is set up in this profile. Next. So the client already has the key. The interesting question is, how does the server get the key? Because it's never sent to it. And the idea is that the server can extract the key from the access token using one of several potential methods. And it might be encrypted by some key shared between RS and AS. So again, these have a pre-existing security association. They have a way to talk to each other in secret. Or it might be derived from the access token, for instance, by hashing it. We're using HKDF SHA-256 as one way of doing this. Again, we're using a common shared secret between RS and AS to do this, and derive a key from that based on the access token and the common shared secret. So we don't have to send it encrypted, but in the end, it's essentially the same thing going on there. And the new thing in Dash 01 is the third way is to just have a key ID in there. If there is some other way for the resource server and the authorization server to know what keys they are referring to, they can use a key ID. So this is in the DTLS setup.
So there are essentially three different ways to get the key, which of course then leaves a couple of options. Do you see a challenge with then interoperability? Like, do you implement all of the three, or do you implement only one and the client supports, or the authorization support server supports all of them, or how is it then? Do you think that would be deployment specific, or is this?
Well, it would be authorization server specific, because this is kind of happening in the security association between the resource server and the authorization server.
Right, but they still need to have the same code, which sort of could create some friction if there's three different techniques.
They need to agree on a way of doing that. And since we are not discussing the security association between RS and AS, we are not discussing how to agree on that.
No, not the security association, but the procedure for ultimately getting to the key that the client and the resource server use, because there's one key transport, encrypted key transport, the other one key derivation, and then there's one sort of out-of-band referencing.
Right.
But do you think it would be easier to just just define one? Because ultimately it's like, doesn't really matter that much.
Well, originally we just had one, and then people said they wanted to have the other versions as well. I wouldn't mind cutting down on things there. So maybe that's a valid thing for people to comment on, which of these key agreement methods actually make sense here for their deployment. But in the end, it's kind of like selecting the cipher suite between the RS and the AS. So they have to agree on this in some way. Yeah. And of course, it would be nice if we didn't have too many ways. John, you look like you want to say something. Oh, good. Okay, so yeah, I already talked about updating authorization information, so there is not really much new here. You either put it to auth the info, or you renegotiate the details session. Next slide. So this is still an individual draft. At the last meeting, we pretty much had, I'm not a chair, but I still can say that, pretty much had in-room consensus that this should be a working group draft, but then we only had acting chairs there, so they said we cannot do this. Dash 01 has mostly clarifications in it, plus this new key ID thing. And as usual, there are some small fixes that happen after the moratorium that are on the GitHub site. There are two implementations being developed right now. Ludwig is working on one in Java, and Olaf is working on one in C that would go with libcode and TinyDTLS. John.
Yeah. Thanks, John Mattsson, Ericsson. Two questions or comments. First, I think you should commit to adding TLS. I think the changes will be very small.
True.
Yeah. And I think, yeah, TLS, now that CoAP is specifying TLS as well, I think yes, you should add that and maybe change the title. Second question, which version of DTLS does this apply to. I don't think the draft, I just read the draft, I can't find any mentioning of which versions it applied to, which is
I hope
do
there
not
is a
apply to.
reference to 6347 in there, but yes, this is all about 1.2 because this is what CoAP is specified for. And sure, as soon as 1.3 actually comes out, we will both have to look at how CoAP actually uses that and how profiles like this change. Do you have an idea how this would change?
Think most would work. Maybe the Cypress negotiation is different, and then there was some requirements on PSK, pre-established PSK. At least in the last version of TLS. I don't know if it still is. Yeah.
But what helps here, for instance, with 1.2 is that PSK identity is supposed to be UTF-8, and that's of course nonsense for this kind of application. It would be nice if we didn't have the problem anymore.
Yeah. Basically, I think specify which version applies.
In 1.2, it's not UTF-8 on the wire. It's just the problem was that you typically had the usage was within browser, and the question is what format does the user enter it, and it's how is it passed to the software? Because as you know, like if you type in, let's say, as you want to two cases. So if you have, let's say, a hex representation that is passed to the software and it understands it as string characters, then obviously that will mess things up. So in order to avoid that, there was one uniform encoding chosen that passes from the UI to the stack. That was referring to this.
Yeah, but you're telling us what you know about why it was done that way.
Okay.
If you read the spec, it's kind of a requirement. So people who are implementing it might implement that as a hard
okay
check.
That's unfortunate.
So that's why we thought, okay, base 64, this one.
Okay.
Yeah. I think it's ready for working group adoption.
Thank you. So are you going to ask the questions?
I could, but I would also like to have Kathleen to speak in, like, because currently it's not under a chartered item. So we have these other documents. So obviously she needs to approve addition of new working group items in the charter. So I think that would be good to get your confirmation about adding profiles. Now, it would make sense to me. But of course, ultimately it's up to the AD to decide.
Could I just comment on the charter? The framework is not, if we only settle for the ACE framework, we have not completed the charter. So the profiles are the missing part. All the milestones may be missing for the profiles. They are understood, I think, by the charter.
So you interpret the charter as that the profiles are already covered in the charter.
They need to be, yeah.
Okay.
They need to be. Sure.
Kathleen Moriarty. So there seems to be enough interest, but I think a whole of the group here is
useful,
an important step. Yes,
Yeah.
yes, because we want to make sure there is energy beyond, the few people speaking, and I'll do a careful comb of the charter to make sure I agree that it is included in there. If we need to update a chart, we can always do that if there's enough interest to get something done.
Yeah.
But it doesn't seem like it's out of scope, right, for authorized or for ACE, right?
Yeah. Okay. So we'll ask a few questions. The first one is whether you agree with the adoption of the document. The second one is whether you object. But then I would also like to hear about who would volunteer to review the document.
Can I ask one question before you ask yours?
Sure.
Who has read a version of this profile? Thank you.
Yeah, I see maybe 15 hands. Mm-hmm. So raise your hand if you think that we should adopt this document, this ACE profiles document. 2, 4, 6, 7, 8, 9, 10, 11, 12, 16, 17, 7. Who objects against adopting this document as a working group item? I see none. No hand. And who has the energy and time to review the document. So you see, I see Jim, Michael, what's that over there? Okay, Sean as well. So let's say about 4 or 5 hands. That's good. Who's interested or has time to work on implementations? So we have a few of them, people here. Ludwig, that's excellent. Jim, perfect.
There was one in the Jabber ring for adoption as well.
Who was that?
Rezno Navas.
Yeah.
Okay.
Renzo.
Okay. Good. Okay. So I think that was good. So we'll Kathleen will take a look at the chart and we'll add it to the milestone list, and we'll ask the authors to submit an draft-IETF-ACE document.
Yeah, you have to confirm it on the mailing list, but
Sure, we still have to do a confirmation on the mailing list, but
remembering the charter, I think adding a milestone is all you have to do. But go ahead and read it.
yeah, add milestone. Yeah. Good.
Thanks. Hello, I'm Francesca Palumbini. I'm here to present a new profile. So this is the first version of the draft ever published. Next. I put there a slide about the related work about this, and the draft is up there in left upper corner. This profile is based on older profiles, and in particular on the TTLS and OSCOAP profile of ACE. Next. So this is a profile for a co-op pub-sub scenario, and it's based on the co-op pub-sub draft that is adopted in core. And this is a figure for from that draft to describe the architecture. So you can see there is a pub-sub interface. The broker is, if we are talking about ACE terminology now, will be the RS server, so the resource server. And then the clients, which are publishers or subscriber, would be so the ACE clients. Next. So this is a picture of the architecture of this profile. And you can see there are two AS. This is for generality purpose. So this could be only one entity, but in the draft they're described as two. The AS1 has control over what endpoints are allowed to publish to a certain topic on the broker. And AS2 has policies about what endpoints, and I'm talking about co-op endpoints, not OAuth endpoints. What endpoints are allowed to access, which means read, a certain topic. So before this profile takes place, there are some pre-existing security association, which are between the clients and the AS1 and the AS2. And then we have two types of clients. We have publisher and subscriber. And this profile defines two types of profile, one for the publisher and one for the subscriber. And at the end of this profile, you will end up with one security association between publisher and broker, and one between publisher and subscriber. So I'm going to describe this on a high level. If you want the details of what exactly the messages are, you should go and read the draft. Next. So I'm going to start with the publisher profile. The phase one is just use existing profile. So it can be either DTLS or SCOAP. These are defined right now. And this is to establish a secure communication between the publisher and the broker. And this is basically to say that the publisher is allowed to publish on the broker.
Next slide.
Yes. Next phase is for the publisher to retrieve symmetric key material and to communicate to the AS2 its own public key. So basically what the publisher does, it sends tokenless. So this is something that was defined in a previous version of the ACE framework and has disappeared. So I refer to that version in my draft, but I think it was useful. So if the author would consider putting that back in, I would be happy.
Well,
So about comment, you were asking about comments about the, this is one.
Yeah, the reason was, I believe why it was removed was it was a less baked idea. It was sort of like an idea.
Yes. So I use that idea now, and I'm interested in hearing also comments and feedback from you. So what happens is the publisher sends this tokenless request to the S2, and it sends its own public key. And then the authorization server 2 verifies that the publisher is authorized to publish and sends back a symmetric key, and also saves the publisher public key. Next. Then the publisher uses this symmetric key to create COSI encrypt object, so a protected object of the payload, so the payload of the publication, and then adds also countersignature to this COSI object and sends this to the broker. Yes, next. Then, in parallel, the subscriber needs to do its own thing and needs to send a request to the AS2. So it requests to be able to subscribe to a topic, and it gets back both the symmetric key material and the public keys of all authorized publishers. After, of course, the AS2 has verified that it is authorized to read the publication. Next. And then finally, I described this, how to use this COSI object to protect the resource representation of the publication. So when the client the publisher publishes on a broker, as I said, it encrypts the payload of the publication, and it countersigns it. And then the subscriber needs, of course, decrypt with the symmetric key and verify the signature using the right public key. Next. So I tried to list here some main features of this profile. As I said, the AS1 has control over the broker, which means it controls who can publish to a certain topic. And AS2 has control over the topic itself, who can read the publication. Everybody is allowed to subscribe. Not everybody is allowed to publish or read the publication, which means that everybody can request the publication, but since it's encrypted, not everybody is going to be able to read it. The subscribers need to know the public keys of all authorized publishers and the symmetric key for a certain topic. And the publishers only need to know the symmetric key and their own public-private key, of course. Also, the broker is only trusted with verifying that the publisher is authorized to publish. This is done during the first either a DTLS or a SCOA profile, but it's not trusted with the publication itself, and you cannot read it or modify it. Next. And then I added here some notes about this. Leaving the group can be done with rekeying, but how it is done is not currently scope of this draft. If you want more control over who is allowed to subscribe to a topic, you can add an ACE exchange between subscriber and broker. So you can basically do another DTLS profile or OSCOA profile between subscriber and broker, like the publisher does. And symmetric only can be done easily based on this, in the sense that it's easy to remove countersignature from COSI and remove the exchange of public keys. But then this is not recommended, and because any authenticated subscriber colluding with the broker could forge publications on the broker. And also another thing I wanted to say is by reading the MQTT profile that is not, I don't think it's going to be presented today, also wants to provide a profile for pub/sub scenario using MQTT. But that scenario is, but that profile basically does not differentiate between publisher and subscribers, and basically does what I say here in the second point, does an exchange between publisher or subscriber and broker with access tokens. So there will be one access token for each publisher and subscriber.
Like presumably the design decision for the MQTT profiles were a little different. Do you know
Yes.
like why they were different?
Sorry, the what?
The design decisions. Why the author has done it differently. Unfortunately, he's not here, but maybe you had a chat.
Well, I think that the point is what I say exactly in this second bullet is if you want more control over who is allowed to subscribe, and in this profile, anybody can subscribe, but not everybody can read the publication. So depending on if you're worried about DOS attacks, or you may want to control also who is allowed to subscribe. And then that profile is very much adapted to MQTT, while this is for co-op.
Sure.
So the differences are, also there.
Ludwig Seitz, another quick comment on the relationship between those two. In the MQTT profile, the broker is trusted. So the payload of the publications are not encrypted. The broker could manipulate them in that profile.
Yes.
So the assumption, or the difference in assumption between those two profiles is the authors of the MQTT profile assume the broker is a trusted entity. Here, the broker is partially trusted only.
What I don't understand is why the different assumptions had been made in these different sort of profiles.
I cannot tell.
Okay, maybe that's something we need to ask if you haven't done so on the mailing list. Maybe there's some different deployments environments in mind.
Carsten Bormann, both approaches have their place. So there are situations in which the broker actually is trusted. So go ahead with something simple. And there are situations where you need end-to-end security, and then go with something like this. So I think both approaches are valid. We don't really have to do anything on the co-op side there, because we already have a way to have a broker in there, so that there's no new profile needed. So I don't know much about the MQTT profile, but I think this is here a really interesting work to get the end-to-end security we want.
I think next it's just thank you. And
Whoa, not so fast. Ludwig Seitz, I have a quick question. I read the draft, but I'm not sure it was in there or not. Is there any mechanism to update the public keys that the subscribers have if a new publisher gets authorized to publish on a topic?
that's not in there right now.
Okay.
Actually, the much more fun part is when a subscriber gets, when a publisher or a subscriber gets deauthorized. Because that's a classical leave event in a group communication scenario. When we discussed this, how to solve this with co-op observe, it's rather obvious how to do it, but it still has to be done.
This could be another document, I think, or
Hi, Randy Turner. I had a quick question. The PubSub co-op document talks about two broker scenarios, one brokerless. And I believe, Michael can correct me if I'm wrong, but the broker can be a real thing or it can just be an interface.
Mhm.
Is there anything about this profile that precludes use in a brokerless environment?
not right now.
Okay.
But if there is interest, I can. So I'm looking forward for feedback and comments. So
Maybe also like who has, so this was a first version of the document.
Yes.
Who has read the document, this version of the document? We have 2, 4, 6, 8, 9, 10. That's actually pretty good for 0.0 version. So I don't think we had gotten a lot of feedback on the mailing list on it yet, but is there someone of you who could do a review of the document and post something to the list? And specifically those who are interested in implementing or even deploying it. There's also the dependency from the PubSub document, and needless to say that from them, comments would also be appreciated. Hi, Michael. That's why it's good that you're here. Henk.
Yeah, hi, exactly. Hi, I'm Henk. And I just wanted to give a comment because you requested comments, and I wanted to thank you for including a way to prove and sign the data provenance in this profile, which is awesome. Thank you.
Thanks.
So can anyone, well, do I see some volunteers for reviewing the document? I see Michael, Jim, and Carsten, and Sean.
And Jaime.
Did I see Ari as well? Yeah. Oh my God, you will get more comments than.
Yay.
Yeah.
So I can
We'll take
make
you a
one
year.
comment now. Actually, this is not a PubSub profile. It's a group communication profile. So exactly the same mechanisms apply to all other kinds of group communication where you want to separate publishers and subscribers, and also want to have a way for a gating function like the broker here to make sure that only certain content actually gets distributed. And you have that in a number of other situations, and I think this is all applicable to those other situations as well.
That's a good observation. So I think we should take that into account in some of our other discussions that we had on group communication earlier this year.
Yeah.
Excellent. Okay.
Thanks.
Is that a link to the code or is that a link to the draft?
That should be a link to the most updated version, but it's not up yet. Okay. But it's going to be very, very soon.
Are you working on implementation as well, or?
Not right now. Oh, no.
Hi, so I'm John Mattsson Eriksson, and this is version 05 of ad hoc. See now that I did not embed the right font, but hopefully it's readable anyway. So what's new in 05? There's quite a lot of smaller changes, but I think the large change was the 04 version when we went from a 2-message exchange to a 3-message exchange. This can be seen as an updated version of that with the following changes. I think we have simplified the protocols, and also the protocol specification should be easier to do a security analysis of the protocol now. We have added explicit session identifiers, each in 2 different, one in each direction, after a suggestion from Jim Shaw. And big thanks to Jim for his many suggestions. We have added explicit extensions so that an application can send additional data, for example, authorization tokens. We have changed the message structure. All ad hoc messages are now CBOR arrays, beginning with an explicit message type. Makes it very easy to find out which message it is, and it also makes it easy to analyze the security. We max, the max and the key derivation are now bound to all the previous messages. Previous messages are included in these. We have simplified and strengthened the key derivation, and to save memory, we are hashing old messages. I will quickly go through most of these changes. Can say next slide, please. So there's a new overview of ad hoc with asymmetric keys. We have party U and V, and which are the party that derive the shared secret. Can take next slide. So these session identifiers, they are new. In the old version, the nonces NU and NV was used as second identifiers and nonces. Now we have added explicit session identifiers. And this actually makes the per packet overhead smaller because these are much smaller than the nonces. And it also means that these session identifier can be reduced by application protocols. So, and that is exactly what we are doing when ad hoc is used with OSCOAP. This also shrinkens the per packet overhead of OSCOAP instead of deriving random session identifiers from ad hoc. Next. NU is the nonces, no changes there except that we don't need to send as many because now they're only used as nonces, not as session identifiers. Next. These are ephemeral public keys, exactly as in the last version. Next. Then we have algorithm negotiation. This has been slightly changed. First, the algorithm negotiation has been moved out from COSI into CBOR arrays instead. And in the last version, there was a single signature algorithm negotiated. In this version, there are two different. So party U and party V can use different signing algorithms, which makes sense. And this was also a suggestion from Jim. Next. These extensions, they are new in this version. Now they're explicit. And these are meant, extension 1 here is meant to, for example, add an authorization token that was previously sent as in a COSI header. But there are also extensions in message 2 or message 3. Yeah. Next. Here are the COSI encrypt 0 objects, and they are, as before, encrypted with different keys. These are AAD, so there is both encryption and a MAC. But the key derivation has slightly changed. So now the keys are derived with basically all available information, previous messages and everything in the current message, instead of a small subset. Next. Then we have these IDU and IDV. This contains the certificate or raw public key of party U and party V. And what's new in this version is that we are making use of draft shard COSI X5.09, which specifies how to use certificates X509 certificates with COSI. And this makes it a lot easier. Yeah. And yes, and then there's the signature objects, COSI sign 1, different algorithms, and nothing new. You can take next slide. And here we have simplified the AAD handlings. Now there's a single structure used in both the signature and in the MAC algorithm. And all previous messages are included in these algorithms, in this structure. So an AAD3 contains message 2 and message 1, and these are hashed to allow the endpoints to store only the needed minimum memory. Next. And here as before, ad hoc is specified with both asymmetric and symmetric authentication. And the document has been restructured, so there's no one common part with key derivation, how to transfer keys, and then there's one section for asymmetric and one section for symmetric. In general, I think the new version is 10 pages shorter, but hopefully easier to understand. And the difference in the symmetric case is that, of course, we remove the signatures. The key derivation has been changed from the last version. In the last version, the keys derived from ad hoc was only based on the Diffie-Hellman secret. Now we derive keys from both the pre-shared key and the Diffie-Hellman secret, as well as all information in all the messages. We also added AAD in message 1, and this has two benefits. First, you can encrypt extension 1 with the PS. This is purely based on the PSK already in message 1, and party we get proof of possession that party U actually has the PSK. And this may help against denial of service attacks. Next. We have also changed how ad hoc integrates with OSCOAP. There is no more embedding in OSCOAP messages. Instead, ad hoc is always sent as a payload. It looks like this. And then, as before, OSCOAP input parameters are derived from ad hoc. What is new is also that the OSCOAP identifiers are taken directly from ad hoc. These are these session identifiers becomes sender and recipient ID in OSCOAP. Next. And here's how it relates to other work. Don't have to go through it, but take a look if you want in the slides. Next. And then summary and next steps. There is already one implementation of this new 05 version by Jin Shad. There's another implementation in progress by 6. And there's an interop planned before the summer. There's some specific proposed changes under consideration, but nothing major. On a non-technical, not very technical at least, but we plan to add test vectors and more detailed error handling to the next version. And the plan is to introduce this during Eurocrypt, the CFRD session at Eurocrypt, and ask them for review. Yeah, Mohit.
Could you go back to the, sorry, Mohit, could you go back to the slides with the ephemeral public keys?
Stop.
Yeah.
Which
so for example, this is fine. So now in message 1, so you already, so is it this algorithms, does it propose a bunch of them, or does it like just say here is one and then the other party has to just agree to it?
Yes, it only proposes one. And if party B would not support that, he has to send an error message. Yeah, and then party U has to resend.
So the public key is already encoded with that?
Yes. Yeah, party U chooses one algorithm.
So, Michael Richardson, so I make sure I heard you. So in the ALG1 there is a singleton, not I will propose several things, and the responder could pick one. So you're saying it's an agreement.
So party U chooses one and only one algorithm, and then party B says okay or error.
How do we migrate to? Go ahead. Yeah.
John, you're wrong. You actually propose several, and the opposite side chooses one.
Wait, but then how is the public key encoded? So if you have like different cores, you propose different cores, but you are sending key in probably encoded as well.
The one thing that is basically singled is the ephemeral key. send one, and if it's not liked, then that's thrown out.
I support EDDSA, one of the cores, and then P256. Now, which key do I send? Which encoding do I use? Like in the power, the ephemeral key.
The curve and key type for the ephemeral key is the sender chooses one, sends. If you don't like it, then then that's going to be an error message in the protocol.
I teach you that.
That wasn't my question. I'm glad we had it. Michael Richardson. Can you go to the slide with the OS co-op embedding? Oh, you're back there. Oh, okay. Sorry.
Nicely done.
Don't you have a remote control?
You tell me that. No, actually, I don't need the slide. Which one?
The one with the OS co-op embedding, because that will be the clearest.
OS.
Back one.
Next.
Back one. Back two. Yeah, there you go. Okay. Hi. So one situation that I guess I want to explain that I think is valuable is the question of what if the server is not prepared to answer message 2 at this time, but does not wish the client to keep asking because of bandwidth. So would like to reply with a 204, yes, I heard you, but I'm not ready to actually proceed with the protocol. And so I'd like to have some kind of a split at that point. And I think that the server is then going to initiate with a post back to the client at that point. And so I wonder whether or not we need more separation between the kind of post and response and the URI paths, or between message 1, 2, and 3, or whether that's really too complicated.
Yeah. CoAP has something called a separate response, which allows you to send an egg and make quiet the client, so it becomes more patient.
Awesome. That's exactly what we want, and can we make sure it's in scope then?
And there is a draft which proposes actually the similar thing as done by HTTP, such that you wait and you get in the... Okay. Peter van der Stuk, sorry.
Hannes Schwennig with my chair hat off. When you look at the exchange, it reflects my fears that I had all along with this work. Namely, that we are essentially rebuilding the TLS handshake in a step-by-step fashion. And you've just exercised that to me in the best possible way. And there was obviously a lot of feedback on the TLS exchange and security research, formal analysis, cryptanalysis, all the full-blown range. And we are doing something similar. It starts off with very similar algorithm negotiation, then it adds some identifiers, and it soon will add a session resumption mode, and so on and so on. And zero RTT and all this sort of goodness that we have seen in the TLS working group. And while we could actually reuse some of it, because the handshake itself is not the main difference would be it's not cozy encoded, it has a different encoding. And the interesting thing is that the broadband forum has actually been looking into this, as I was told. I'm not member of the broadband forum, or ARM is not member. And I was told on the weekend that they have successfully run the TLS handshake as an application layer security mechanism already, and that's what they are trying to use. So maybe they can share some of the insight and design they have done and their experience, but it sounds like a lot of work to me, sort of redesigning a security protocol. It's not a piece of cake, and you need the implementations, you need the deployment, you need to have people buying the education, etc., etc. I think we should take that a very conscious decision. Yeah.
So answer, this is an implementation of Sigma I protocols. I would say that the security proofs, high-level security rules are in place. I would say that this is a much simpler protocol than the full TLS handshake with all its options. And as Hannes already said, the benefit is to be able to reuse a COSI implementation that you have in place instead of having to implement both COSI and TLS.
Dave Taylor, different point, but same slide. The URI path, you're using fixed URI paths that are not under .well-known. You're not supposed to do that. Just change the URI path. If you're going to have a fixed URI, which you currently do, you need to be under .well-known. RFC 7320.
Okay, thanks.
Carsten Bormann, I think we have implemented DTLS as an application layer exchange in 2013 or so. There's actually an internet draft out there. So that's certainly possible, but it doesn't really take away from the point of trying to do something that is much more narrow and much more well understood, so you know what properties it's going to have.
Dan Harkins, can you put the symmetric key example up? Yes. So you're driving K2 and K3 from the PSK and the Diffie-Hellman, right?
And from basically all information in message 1 and all possible information in message 2.
What's K1 derived from then? I read your draft. It's very nice, very well written, but I can't, for the life of me, I can't figure out how you're deriving.
Okay, K1 is derived from the PSK and from the information in message 1.
So the only entropy in K1 is the PSK, and then you reuse PSK as salt for.
No, you have good sources of entropy. You have NU and EU. So you have a lot of entropy, which you use together with the PSK.
But those are known, so you don't have any entropy because you're passing out in the clear. So you're driving
the PSK is secret, and then you add a lot of public entropy,
so
just like you should.
Okay, so K1 is using the PSK as the sole source of secretness, and then K2 and K2 are using the ephemeral Diffie-Hellman.
Yes.
Plus the PSK.
Yeah.
Okay.
But it's good point if it's hard to understand from the draft, and we will update that.
Just a comment to Jonas Elander, a comment to Hannes there. I think the point here is actually that we're using COSI. All this is based on the assumption that you have a constrained device who is implementing CoAP, CBOR, and COSI or a subset of COSI, and then you'd like to have a small addition in terms of code, and you want to get a key management protocol, a standardized key management protocol. That's why this is not same thing as TLS.
Yeah, I guess that the ball is with this type of work. It's really with Kathleen, I would say. I don't know what to say about that.
To add some information, it's used by 6-ish.
So given where this state is, where this works in discussion and looking at it in implementation and so on, I think this would be a typical place where we would go for working group adoption. Now, we don't really know what working group. That's an interesting question. But there are enough people in this room who understand the subject well enough that we could ask the question without even identifying the working group. So that's what I would propose to do now.
Yeah, and I will. I think I'll let Kathleen run that show because I think I'm biased on this one, and I want to excuse myself from this topic. I said what I wanted to say.
I just want to remind you that we already discussed which is the relevant working group. We did that 2 meetings ago, and the general opinion was that ACE is the relevant working group for this document. So we can go back to the notes and look at that.
Well, it's definitely something that requires, I don't think it's covered in the charter, so you have to,
Okay.
um,
I'm not saying the mic. So, Kathleen Moriarty, if the working group wants to adopt it, then that's what we do to add something to a charter, right? We decide if the working group is interested. Now, 2 meetings ago, I'm told the minutes, your memory is better than mine, already reflected that there was interest. So why don't we just poll again and see the interest and see if this is something we want to add to the charter to work on. So how many people have read this? Okay, how many people are interested in this work? All the people that read it. Okay, sure. Can you raise your hands again? I was just doing it rough, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Maybe 14? This was had read it, right? Oh.
okay.
All right, one more time. Have read it, and I'll stand up so I can see better. All right, so 11, 12, maybe 12. Anyone in Jabber? 13. All right, so who's interested? All right, so there's a little more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think 15 plus the interested person. Is there anyone else in Jabber interested? Okay, so who's opposed to this work coming in?
I'm not opposed. I like the idea that you said you'd keep it small and then features won't creep in. We're not recreating protocols. So I'm looking forward to no options for extension, extensibility, and all kinds of other things.
Okay. At the mic and say your name, please.
Mohit, there are options for extension, so hopefully the authors will try to stop rebuilding TLS.
So the core document not having those extensions, the extensions, if they come later, we'll discuss that later. Is that fine, Sean? Okay. It seems like there's reasonable interest. There's some working groups that only have that many people in them, so. Who wants to deploy? That's another good question. Who's interested to deploy this? All right, that's fair enough. Okay. So if you guys want to come up with a charter proposal, put this to the list, come up with a change to the charter, and then we'll go through the formal adoption process on list to confirm. Thank you.
Thank you.
You next.
Okay. Thanks for the invitation to present this paper. It's not in the charter. Let's go. Next one, please. So the EST over CoAP-S draft is actually an extension to what is going on in the ANIMA working group, where they're looking at bootstrapping devices into a secure network. So if an unsecure device, you add it to a secure network. One of the things that this BRSky is using is called EST. It's it's based, and that's currently based on HTTP and TLS. We are looking forward to using also BRSky for small resource devices, and for that we wanted to have the EST running over CoAP and UDP and DTLS to support it. Next one, please. A small what BRSky is about. I mean, Michael will certainly correct me. So there is a pledge, which is a node which is unsecured and wants to add the secure domain, the secure network. And he asks for a proxy which can help him so that he sends a message to the proxy, and the proxy routes the message on to the EST server. Thing to remark is that the joint proxy is just a kind of router. He gets a message from insecure node and then forwards it to one single destination he's allowed to, which is the registrar where the EST server is loaded. Well, the registrar talks with a master vendor to see if actually this pledge is allowed, and etc. And the EST protocol makes sure that the final keying is transported to the pledge if everybody agrees that the pledge should be added to the secure domain. Yeah. Now, I'm not going to look anything about the BRSK. This draft is just about doing this red part. There is the pledge to the EST, and which is just is making this channel secure, and which is then not interrupted at the joint proxy, but it just continues. So it's an end-to-end secure channel which we're supporting. Okay. Any questions here? No? Good. Oh yeah, so what is supported are certificates, which you all know about, and there are vouchers, which is also defined in the ANIMA voucher, and the voucher is about the ownership of the node. Yeah. Okay. So why are we interested to do it like that? So if we have this registrar with the EST in one box, and which will probably be available for the ANIMA networks, then if we just add this co-op interface on top of it, we have just one box, and the whole registration of devices to the secure network is similar both for the standard HTTP devices and for the small devices. So we think that is an addition and will help actually in large networks to which IE3 devices belong, that this will happen securely and that everybody feels confident that it works okay. Yeah. So that is it. So what is the contents of the draft? So there are not too many changes. We specify the DLTS and co-op, and because the messages are rather long, we need to use block, and we show how it can be done and what the messages look like. We have a text where we have the conformance with the ACE profiles. I think there will be some comments about that. The difference with EST is that we do not have any human password intervention, which is foreseen for EST, but we think we are doing machine to machine, which is not needed, so we've removed it. We don't do full PKI messages. We only have simple PKI messages, also because of the incredible length of the message that would be generated. So we're looking for small messages. We have some extensions on top of the EST requests, which are needed for BRSKI, have been added in this draft. And what we have done as well is the EST proposes very long URI paths, which are lots of characters, which fills up the message, and we wanted to make that shorter. So also the URI path is smaller, and the base can be discovered, and we propose, for example, that is /EST. And another thing which we have done, that all the payload format, PKSCS, 10, etc., we use CBOR, which currently they use BDSD64, it's called, where you have 6 bits, which are encoded in 8, and with CBOR we have 4 in 4, which gives a 25% reduction in performance. The CBOR extension is not a problem because the ANIMA guys already use CBOR in their GRASP messages, so I don't think it's major. So the other thing that we're looking at is how this compares with the works in 6TiSCH, the ad hoc work and the OSCO work, and we'll do presentations afterwards. Okay. Now these are some details. The extension for the BRSKI is the request voucher, which uses the voucher request, and the other ones are just the well-known stuff which is sent by EST and which is, I think, okay. Last one. So what we still have to do in the draft to make it more complete is to get operational parameter values added. So what are you going to do? You have to give examples, what it looks like for all the endpoints. Security considerations, it's not in yet, and other things. And the question is, are there any plans in this working group for this draft?
Any feedback? Elliot, are you coming to the mic or are you leaving?
Hi, Elliot Lear.
Hi, Elliot.
So I think this work is very important, and it's a really good start. I don't know if ACE is the right working group for this, to be honest. I think it may be that this needs to go to ANIMA to be completed, but I would suggest that the various working group if the working group chairs haven't done this already, there should probably be a discussion amongst them to figure out where it goes.
It's a discussion. I mean, there's also talk about adding this to the key infra one, but as it's so extensive and it actually depends on quite of the knowledge here about the security, we thought the best way might be here. I also talked about it, if it should be in the core working group. They also thought that ACE might be the better place.
Okay, so if that discussion's already had, I would like to see the work go forward in coordination with the underlying Brewski and Docker drafts.
Okay. Elliot, do you think one important decision is whether this is strictly tied to ANIMA, and you mentioned a couple of extensions that are very ANIMA specific, because the initial work of ESD was really about like you enroll certificate, you request a certificate, authenticate that request, and then you get sort of the key signed. There was a generic protocol in some sense, but with is ANIMA adding some stuff that makes it very specific to the ANIMA environment, or is it?
No. In fact, I mean, Michael's walking up here. He can go into much greater detail, but in fact, it's just really meant to solve that problem, Hannes. Is you want to end up in this end state where you have the right operational certificate and the right trust anchor inside the thing.
Hi, my name is Daryl Piper. I'm concerned by what I'm hearing here. And let's start off with, I think I heard that this isn't in the charter. Is that correct?
That's true.
Okay, so you guys need to do something about that and get this in a working group, what is chartered to solve this problem. Whichever working group that is.
Yeah, I think the question, we have a couple of questions. The first question is obviously whether people want this at all, besides the authors.
Yeah, that's a good one to ask. Do we want this at all?
The other one is, my understanding was that there's some competing effort, also some other solutions. So the solution space seems to be a little larger. That would be the next question, like which direction do we want to go? Absolutely. And then the final question, and that's another question for me, but for the ADs to hash out, is where should that work actually take place? That's why I was trying to figure out whether there's a dependency on the ANIMA.
Okay, good. Okay, sounds good. I'm hearing layers upon layers and protocols and protocols and packets and protocols, and that violates the golden rule of computer security. Keep the trusted computing base small and simple so that you can understand it. That's all.
Okay, that was our purpose here, actually.
Dave Taylor. So I don't have an opinion on where they should go, but I'm going to keep harping on a point until there's nothing more to harp on, and hopefully I can sit down and never say this again in future IETFs. Don't use fixed URIs. This draft is actually better than the previous one that actually does say that the host can do whatever it wants as far as using /est, you're using something else, but it's recommended to use /est. So it doesn't at least make it a must like the previous draft did, but even recommended is bad. You can use it as an example in the document, but don't even say it's recommended. And so I will keep saying that in every draft that uses fixed URIs.
I feel extremely comfortable with that.
Max Pritikin. Agnostic as to where the work happens. I agree with the basic goal. I will note that the Anima Brewski draft does not actually use CBOR today. It uses JSON. And if this change is important, which I agree that it is, but that feedback needs to be very clear so that we can update the Brewski draft or make sure there's alignment.
The grasp one, which is part of the ANIMA, uses the CBOR.
I agree that CBOR is used within the ANIMA space, but there is a disjoint because the Brewski draft does not. And so the feedback that this is important for those constrained devices needs to also happen on the Brewski side, just to make sure it happens.
Michael Richardson to add. I wanted to mention it's Brewski, as Max said. We work really hard to make it Brewski.
Sky is not
to drink. And
that one.
BRSKI is not the name of the protocol.
The letters.
Just let you know. Yeah.
Okay.
I don't think it belongs in ACE. I think this work needs to be done. I think you should keep working on it. We actually consciously ripped out all of this COAP CBOR stuff from Brewski for the simple reason that we didn't know how to do it well yet. And we decided that rather than rat-holing on that aspect of it, that we realized there was nothing that prevented us from adding it later as a second document or as a BIS to this document or something. And so we just said, you know what, let's just go. In particular, the question, which we discussed just before, of do you want to run COAP over DTLS, which I think you're proposing, or do you want to run COAP with OS COAP, is a question, and we don't want to have that argument right now in ANIMA. So we decided to do neither, and that's it. So I think that it may be later on that this would have a place in ANIMA. I don't think it quite fits into our charter right now, but because constrained devices are a little bit excluded, we're not disallowed to address them, but we're not encouraged to take it on. So
two answers. I like the building block aspect. So you have this Brewski and and it has all these different aspects and building blocks. And I like the part where you could take out a part and replace it by another one. So that I liked. Second one, I know you didn't decide anything, and we are very much looking forward to having the scope of EST. So we thought we should go forward and help you a little bit here.
Right. So so please let's continue with this, and ANIMA is after lunch. Okay. And so, but I don't think it belongs in ACE. I think that ACE is for something else. Authorization.
Oh. So I guess just one minor, Sean Turner. I also have a document that extends ESG. Exciting. One of the crazy things they wanted to do is put down an XML file that you could download. And of course, everyone's like, no one does XML. I want JSON. So there's a way that the client could indicate what it supports with this content accept header. And so maybe that'll get you out of the JSON CBOR or whatever. Maybe someone will come and yell at me later, but that's the worst idea ever. But that allows the client to tell you what the server support, or what it supports, and then the server can just give it back what it wants. So basically, most of the effort is then on the server to support as much as possible. It makes it a little bit easier on the client to only have to pick one. So I don't know. Maybe that's a way forward.
No, I'm not going to yell at you. I mean, anyone who wants to switch away from XML to JSON is welcome at my table in the bar. But come on, use S expression. People can read those too.
Okay, thank you.
So Kathleen Moriarty, AD. This group has put forward one document so far for publication. Milestones, so I think just looking back, not just at the charter to make sure the other work fits, but your milestones need to be updated. I would like to understand priorities for the working group and how we can streamline and start getting stuff through. So as we look at new work, I really want to make sure we're taking care of what we're taking on.
Yeah. Okay. So we'll keep it as input to the group and entertain it further.
And we'll see how it evolves between ACE and ANIMA. Okay.
And specifically, since we now have another presentation related to the same topic, just in a different flavor.
Good. Thank you very much.
Thanks.
Okay. Before starting, I'd just like to second what Kathleen said here about not taking on more work than we have already on our table. So this draft is actually another draft on certificate enrollment, which may or may not be what we are going to do in this working group right now, or in this working group at all. But anyway, so this is a proposal which is not a competitive proposal, competitor to the previous proposal, but a complement. And if you look carefully at the people standing behind this proposal and compare it with the previous proposal, you will see that there is an overlap in names. So that's sort of supporting the statement that this, at least those people think that we need both solutions. Next slide, please. So this slide is essentially saying something I stated previously, that we have work ongoing on application layer security, And it is useful in certain use cases if you have co-op, CBOR, and COSA implemented, and you want to do security protocols on top of that. You don't have to implement TLS. And that's essentially what this draft also is proposing, that given that we have these primitives, can we do certificate enrollment on top of that? And of course, yes, we can. Next slide, please. So this draft is proposing something analogous to the enrollment or secure transport, but instead of transport layer, we're using application layer security. So the analog, so EST is in itself based on the certificate management over CMS, CMC, and it's authenticated with TLS. And this proposal is then taking the CMC protocol and authenticate it with application layer security. So the analog of the TLS handshake is ad hoc. The analogs of the record protocol, is OSCOAP, and this draft is the analog of EST. Next slide, please. So if we go down into the details, you could look at this as a two-phase. First, there is the key establishment phase, and then there is the actual enrollment protocol. So instead of an enrollment protocol is a request response message in its simplest case. There is a certificate signing request, and it comes back a certificate. And instead of using TLS record layer, we are using OSCOAP. So this figure is obviously a simplification. There could be like a registration authority instead of a certification authority. There could be proxies in between, but on a high level, this is essentially the protocol. Next slide, please. So that was phase 2 in the previous slide, and now we need to explain how we got the keys which we used for protecting the enrollment request. And that's then the key establishment protocol. In this case, it's ad hoc. And then there are a couple of variants you could do depending on who initiates the message exchange. In this case, we propose that the CA side is initiating, and that has the advantage that the client gets authenticated first, which means that if you have an authorization step, then that could happen before the protocol is completed. So the server or the CA say is contacting an authorization server, which could be the MASA from the Brewski setup. He gets an authorization, some authorization information, could be an ownership voucher or some other information that authorizes this client or this device for this network, and then that token could be passed on to the device, and the device could also verify that it belongs to this network. So that's one way of doing key establishment, but there is also another way, and that's the next slide. Since this is the ACE working group, we should obviously look at ACE methods for authorizing access and establishing shared secrets. And this is actually the offline client offline case, which we've been discussing previously, which is included in the ACE framework. And it's based on the use of ACE client token, which is a deviation from OAuth, and we introduced it because it's useful in the client offline scenarios.
Where's the certificate signing request here? Or is that not?
So this is phase 1.
Oh, okay.
And that establishes the key, and then you do the phase 2, which is the signing request and the certificate response. So in this case, in the previous case, we were assuming that the client had established a credential, for example, during manufacture. It could be a manufacturer certificate, and that's used to authenticate. In this case, we instead assume that the client has acquired an access token during manufacture. And this access token is being presented to the network, to the resource server in this case. And it makes an introspection request based on the access token to verify that this device is actually authorized to join this network. And it gets back an introspection response, which then could confirm that this is the client and this is the key of the client. And in addition, there is a client token. And this client token contains the key for the client. So that's passed on to the client, and it could also contain authorization information. So with this exchange, you also get the shared key and mutual authorization, and then you're ready to start phase 2, the enrollment protocol. So that's basically the contents of the draft. So the two alternatives for phase 1 and the phase 2, and it's based on application layer security. Next slide. Oh, that's the last slide. Any comments?
Mike Jones, Microsoft. I'm trying to understand the motivation for the client token. Is it so that you're not generating keys on the device?
So the client token in this case is used to establish a key between a client and a resource server which has never met before. So the client is offline and it can't contact an authorization server because it first needs to join a network. And that's a catch-22. So in order to join the network, you need to first go via, or in order to contact the authorization server, you need to go via some point of contact in the network. So that gets you the contact with the authorization server, which provides you the key to the client, which a client later uses for authenticating to the resource server. So all this interaction between client and resource server is unprotected. This is the way how they establish that key. Does that make sense?
I think so. I'll look some more. Thank you.
Okay.
Michael Richardson, it sounds to me like that some of this was confused with the the routing information to get the traffic through in your description, and I was confused by that because I didn't think that's what the client token was about. Okay, but all right, good. I'm just confused by the fact that you said it was offline and yeah, okay.
So this actually ties in with the next presentation, which is dealing with disconnected clients. How do we get information to the connected clients so it can start? It can get authorized and start secure communication.
Gern, is it sort of a fair characterization that the both proposals have one thing in common, that they used the existing certificate signing request as a way to communicate that information and to work with the existing infrastructure?
Do you mean the both phases here, or this proposal?
Both drafts.
Okay.
Is that fair to say?
So both drafts are, I would say, very closely linked to EST. And the difference in the previous draft is that you replace HTTP and TLS with CoAP and DTLS and some other things. I hope I'm characterizing this fairly right, roughly right. Peter is not complaining. And this draft is replacing TLS with application layer security. So with CoAP and application, HTTP and TLS with CoAP and application layer security.
Right. So there seems to be, at least in a group, we have one camp who likes to use TLS and DTLS, and the other group who doesn't like it. And so that's why when you said that they are not in competition, you are referring to let's standardize both because they are providing security at different different layers. Is that sort of fair? Okay.
Exactly. And I mean, it is a tradition in this group that we are working both on application layer and on transport layer. So whether we like it or not, that's sort of the set of drafts we're working on.
So this means it's something like a both draft just change the network tier, but for the authorization, how a device is authorized to get a certificate, that's independent. That's outside of this. Is that right?
Sorry, how?
So you change it for application security versus DTLS, right? Or only TLS. That's more like how to handle the handshake, right? And the network tier. But how a device is authorized to give in a certificate, that's not covered here. That's still traditional 3 ways or 4 ways or different choices for authorization.
So how? Yeah, exactly. I mean, it's correct characterization of the difference.
Basically,
Yeah,
no, there's only one.
Sorry, do you want to say something?
No, I think what Michael Richardson says is there's only one anymore. That was covered in Peter's talk previously, that the number of options are sort of reduced. At least that's what the current proposal is.
Authorization. Say earlier, ESD has 3 ways, right? 3 methods to get authorization, and you can use a application password.
Yeah,
you
there's
can
only
use
one
a
anymore.
certificate or others, right?
That's right.
Only one anymore.
Only one.
Only one.
Okay.
Okay.
Thanks.
Sean Turner. So Hannes, to your point about 2 different ways, I mean, that was a failing of PKIX, right? They had like 4 ways to do it, and it didn't really help. So it would be really great if you guys could figure out some way to do it once. I know that may be an impossibility, but it would really help, I think, because what ends up happening, right, is people run infrastructures and they're like, I got to do 4 of these. Thanks a lot, guys. And it ends up being a super pain. So if there's some way we can...
I think there are different, sort of like different attitudes to approach standardization. One of the attitudes is let 1,000 flowers bloom and then let the industry figure out, which is a very convenient way for chairs and ADs to approach things because they don't have to then battle around.
Yeah, you don't have to have that. You don't have to have the sword fight, right?
Exactly. So that's the difficult part here, and you've seen that discussion before. So I don't know what to do about that.
Thanks, Pritikin. I recognize that this is written as being around EST, but it actually looks like the bootstrapping remote security key infrastructure flow, and in fact, what it distributes is the voucher. So I would contend that it's actually more towards the Brewski extensions DFC, but that's relatively minor. What I have as a question here, I believe that you include the ownership voucher, and I also believe that all of the other messages here are actually CBOR encoded. Does that then imply you are also expecting the voucher to be CBOR as opposed to the current defined JSON?
That's beyond the detail of the current draft. It's more of a strawman when it comes to, it's outlining the protocol messages, but not going into details. So that's, I would expect we would take the most compact representation available, whatever.
Agreed. I was pointing it out because this is all becoming input back into Anima to say, at least from ACE's perspective, all that should be CBOR. Okay. Thank you.
As a final thing, I think it's also worthwhile to point out that if you use ESD and the X509 certificate, you obviously have to deal with the ASM1 libraries as well, because that's the way how.
And that's a really valid point here, because I see this as a first step that I mean, the certificate formats are not changed at all in this discussion, but I think that's something we need to take forward as well.
You want to change the certificate format?
I would like to have more compact representations somehow, which works for more constrained devices. Yes.
So just Michael Richardson, just to respond to that last point about this, I think, I don't have a proof of code, that one can do TLS with using a raw public key for the registrar, pinned by the ownership voucher, and an IDEV ID certificate that is essentially opaque text, opaque blob in your constrained device that you pass to the registrar, such that the constrained device can get away without doing any ASN1 operations. That the validation of the server is a memory compare between one signed object, which if it's in CBOR, where or COSI, we win, and some GUI that it finds in, the raw public key that the server provides. And so I think that we can do that within TLS, and obviously we know we can do it within OS CoAP. Okay, so I think we can actually get away without any argument about A requires ASN1 work and B does not. I think we can actually get away without having it either way.
But I think both of them use the ESD format. That's what I previously asked, and the ESD, the certificate signing request also uses ASM1 encoding at least.
Right,
and
but
the certificate in there.
I think that we can get away without actually parsing the ASN1. Right, we can mem compare. We can basically say if it doesn't contain this sequence of 9 magic bytes, then it's broken. Okay, but it still looks like ASN1,
I
and we're
think it
good.
would be useful if you write this up somewhere in the document.
Yeah, well, I think I have to implement it first. So,
Okay, so-
but yes, I think we can get away with it, and so it'll look and sound like it's running the full thing, but we don't actually have to implement all of it.
Okay.
Okay, and that's in some ways that's what we do in IETF2 within our certificate signatures. We simply say it's got to have this sequence of, I think it's 5 bytes, which happens to be the prelude to the signature, and that's it. And that's what we've defined. We've defined it that way, and so it looks like a certificate. And if you are doing the full thing, you're great. And if you aren't, you better make sure it's in a library always produces the canonical representation.
Mhm. Interesting. Yep. If you did the investigations, please let us know what the outcome is. Good. Thank you. Thank you, Garen. So how are we doing with the blue sheets? Has everyone signed the blue sheet already? Where's the blue sheet, actually? If you haven't signed the blue sheet, raise your hand and we pass it around. Okay. So we have the offline usage of ACE, and then we had this other bashed agenda item on the attestation topic as well. Follow afterwards.
Hello, everyone. My name is Jintao Zhu from Huawei. You can call me Julian for short. And this is my draft. Talk about the ACE offline cases. Next slide, please. And for the background informations, I think in an actual ACE deployment, either client or RS can be a constrained devices. So there are 3 different possible designations between those 2 nodes in the ACE framework. The first one is between the client and AS, and the second one is RS and AS. And the third one is client and RS. So I think my draft tries to provide an overview of the disconnection cases. Next slide, please. The first is talking about the client ACE disconnection. The first one is that the client has may use to have an self-contained token, and which is expired, and it cannot get any resource from the RS, and so it has to find a way to. So it instructs the RS to obtain authorization information from the AS. My question here is that would it be possible to use the resource server as a proxy to get the authorizations of information?
Your answer on that. So this was exactly the situation in the last presentation when you used the client token. So if you recall the figure with the client token, there's an access token first passed from client to resource server. There's an introspection request, and then comes the client token back. So in that way, the resource server is a proxy for the authorization information contained in the client token.
Okay, but a little difference with the client token case is that my suggestion is to send the authorization information directly through the steps E, and not to like the client token to send back the authorization. The token back to client first, and then do the resource access. Is that something that is okay?
Maybe I missed that point. You want the client token to go through E and F back to the client, or?
No, I mean to send a client asks RS to send a request with step D to get or obtain the authorization information from E, not to only get a client token from the E and go back to client and doing the access further.
Okay, so, but that's the authorization information for the resource server is contained in the introspection response.
Mm-hmm.
And the authorization information and keys for the client is contained in the client token. Is there something else missing? Maybe we can talk offline about this.
Yeah, okay. Okay, thank you.
Hi, Dave Robin, Building Automation Industry. This is now the second time. You're right, this is very similar to the previous presentation where the client talks to the resource server does introspection in that previous case, and here we have the resource server again talking to the authentication server. Okay, 2 times, that's just too much. I've got to stand up and say, when you are bringing building automation equipment online, very often the resource server cannot talk to the authentication server. That's the whole point. You said, is there anything wrong with this? And I'm saying yes. The client very often might be on a laptop talking with Wi-Fi back. He can get to the authorization server, but the resource server cannot. And so, generally in that case, you get some sort of signed information from the authentication server. The client then talks to the resource server, and because of the signatures and everything on there, the resource server says, "Okay, I trust this. I trust that you, client, have talked to the AS. So I'm going to let you do this." But this is the exact opposite of what we normally see. It's the resource server that can't talk to the authentication server.
I think the interesting aspect here is, and we had that discussion earlier in the working group already, specifically since we had such functionality in an earlier version of the working group document, and then ripped it out. The problem is we can, since there are multiple different scenarios, we can basically come up with all different variations. Yes. And the question is, which one do we want to work on first? Which are the most important deployment scenarios we care about first? And at that time, we concluded that the ones that you just mentioned were the most important ones. You are bringing the case forward that there are other scenarios that you ran into where this is not necessarily true. And now the question is,
yeah, I'm just throwing a data point that you said, is this, we're generally seeing the direct opposite of this. Is that
and apparently he's saying that he's seeing something else.
The RS can't talk to the AS, so.
Okay, thank you. And the next slide, please. Okay, this is also a subcase of client AS disconnection, which is included in the ACE framework draft. And this, I think, is agreed with most of the guys here. And the client can get a reference token when it can communicate with the AS and use the reference token to do the introspection procedure afterwards. So next slide. Okay. The third one is, I think the procedure is similar to the second one. So the client asks, when it can communicate with the AS, it asks the AS to send its authorization information to the RS for cache. And do you think it's acceptable for this case?
I'm not sure whether it's acceptable, but we have defined the authorization information endpoint at the resource server. And since the client is allowed to post access tokens there, you could actually allow the client to also do a delete on its own access tokens there. You would, of course, need to manage rights for that so that the client can only delete its own access tokens. But I don't spontaneously see a problem with that. There might be, but.
Okay. So that's all for the client AS disconnection cases. Next slide, please. So the next one is the RSAS disconnection, which is also contained in the included in the ACE framework draft. So there's no doubt, I think, for this case. And next slide, please. Okay, client RS disconnection. For this case, I think it's a very common case in our daily life when you going and I mean, when you want to remote control your smart home devices, you use your mobile phone application as a client and your own hub as an AS and the resource server maybe a smart home devices. So for this case, I think the client should send two instructions to the AS. The first one is to ask the AS to act as a proxy to forward the resource or data access request to the RS, and the other instruction is used for the AS to send the authorization information to the RS at the same time. So, you think it's okay?
I have your answer on that. So the question here is, we assume that the authorization server is a non-constrained device. It's typically an online available device. So if the client, both the client and the resource server can access the authorization server, what is the use case when they can't access, when the client can't access the resource server?
I mean, when you live in your home and you want to control the smart home devices remotely, and you cannot connect it to your smart home devices directly, and you have to use your own hub for this, I think.
So the authorization server can connect your devices, but the client cannot?
Yeah.
Okay.
So you use your mobile phone here to control your smart home or to check on something.
So
that's the use case he's looking at.
Mohit, so yeah, if you are remote, you don't have like Bluetooth access to some smart home device, then you use the hub remotely. I guess that's the use case.
Yes.
Yeah.
David Robin, I don't disagree with that. The hub, this example flow is exactly correct, but please don't call that the authorization server that's doing this function. It's the hub being the proxy.
It's an application server.
If we want to talk about physical box talking to physical box, then this drawing is great, but it's not an authorization server function that's doing the proxying. Put them in the same box, but don't draw it this way.
Yeah, there are a couple of solutions that you can use, readily made the solution, because it's a whole system design.
Right, throw 10 functions in that box called the hub. One of them is called authorization server. Do not add proxying to the job of an authentication server.
Actually, in defense of that, this is specified in RFC 2904 as the agent sequence, except that 2904 was before OAuth, so there's no access token and such. But basically, the idea of this flow is that the client sends its request to the authorization server. The authorization determines the authorization of the client and does the request on behalf of the client if it's authorized, and then
But Ludwig, there's more to that because it's not just the authorization request. There's actually the whole message, the application semantics that need to go on top of it.
This is certainly not covered by the ACE framework as it is right now, and it would require great changes to OAuth to make it cover that. But this is a pattern that has been used before in IETF, so it's not something that was cooked up without any basis in reality.
No, but it was a bad idea. I mean, I just brought up RFC 2904. Okay, that's a virus, folks. That needs to be defeated.
What is actually that RFC? I don't remember that.
It's called the AAA authorization framework. Yeah, this proxied authentication stuff.
I think the AAA stuff actually works very differently than it's actually closer to the client.
Okay, then don't put this there with them.
No, it's different. I think you're mistaking that, Ludwig.
Justin Richer, I just want to reiterate what was said a few bits ago. Yes, this is not a function of the authorization server. You need to keep in mind that the authorization server is not a box. It is it is a function of something. And in fact, the pattern that you're talking about here is very well established in the marketplace and is known as an API gateway. There are a lot of companies that would be more than happy to sell you a single box that does authorization server and proxying and internal authorization calculations and stuff like that, where you put your actual resource servers, you know, down behind them somewhere else. They're more than happy to sell you. There are lots of companies that are more than happy to sell you those. While I understand and appreciate that it is tempting to draw it in this way, because it's tempting to think, oh, I'm getting the access token and I'm validating it here, and then I have some other back channel communication to the RS or whatever. You are really performing a very, very different function in that case. And also to touch on a previous point that was made, something that we need to keep in mind in this group, as Hannes pointed out earlier, is that constrained means something different for pretty much everybody in this room. There's going to be a different part of the system that's constrained in a different way, and that's one of the hardest parts about this work group. That said, I also agree with Kathleen that the working group really needs to solve like some actual problems. There are lots and lots and lots of problems in this space. I don't believe there to be a universal solution. I think we've tried to maybe have one for the last few years and there isn't there, right? But I do think that, you know, with a nod towards people whose use cases aren't getting solved first, I do think that we do need to pick some, solve them, move on.
Thank you, Justin, for this nice summary about the need for prioritization. We unfortunately ran out of time.
Okay.
I saw that you were actually close to your last slide. I think this was a good discussion, good feedback, which we need to bring on board and continue the discussion on the mailing list. So thanks for introducing that topic and bringing up that issue. There are a couple of takeaways from the meeting, and Kathleen and I will work through them and we'll distribute the meeting minutes. And thanks Ari and Sean for working on the notes and the chapter. Thank you guys for coming. And if you have some time later today, come to the OWASP meeting. There's obviously related technology being discussed. Oh, give me the blue sheet. Give me the blue sheet back. Thank you. Thank you. Hey, Nat. Oh, okay.